Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now let's look at this paper, which is paper 6, Probability and Stats 2, October November 2025, variant 62. So now let's look at the first question. The number X of used computers donated to a charity has a constant average rate of 2.4 computers per week. State a necessary condition for X to have a Poisson distribution. So, whatever reasoning that you write, it should be in the context of the question. So, the donation is done singly, the donation is done randomly on a random basis, the donation is done independently of one another. Now, assume that X has a Poisson distribution. Calculate the probability that the number of computers donated during a 4-week period. So 2.4 that was per week multiplied by 4 that is 9.6. So this X now follows a Poisson distribution with 9.6. It is more than 6 and less than 9. So more than 6, 6 is not inclusive. Lesser than 9, 9 is not inclusive. So the next one after 6 is 7, the one before 9 is 8. So basically we need for two terms. So e raised to power of negative 9.6, 9.6 power 7 over 7 factorial, 9.6 power 8 over 8 factorial. And as you have watched other videos, you know that when we are solving this thing, make sure to show all the working. So that means show this working, multiply with this, and then the final answer, get the 4SF answer, and then the final answer. The next one, use a suitable approximating distribution. Calculate the probability more than 50 computers are donated during a 20-week period. 20 into 2.4, that is 48. So now, since lambda is greater than 15, X follows a normal distribution 48, 48 because it's a property of Poisson. The expectation and variance is the same. Now don't forget continuity correction. So we want greater than 50. So that is 50, that is the upper bound, 50.5, lower bound, 49.5. Draw two lines going to the right. One is a blue line, the other one is a green line. And which one should we choose? We should choose the one which is not including 50 because it says more than 50. So more than 50, so the correct option is the blue line. So that is why we have chosen this thing. And then it's back to the basics, that is standardize, get the z value, it's greater than a positive value. 1 minus probability z lesser than 0.361. Let me show you one working over here. So this is 0.361. So where is it? This is 0.3. Then it's 6. So this is 0.36. And then it's 1 over here. So there it's 4 over here. 6406 plus 4, 6410. So this is 0.6410. And then we subtract it. We get this answer rounded off to 3SF. Very simple, very basic. The next question, the random variable X has a normal distribution with mean 10, standard deviation 3. The independent random variable Y has a Poisson distribution. So expectation of X is 10, variance of X is 3 square, expectation of Y is 4, so is the variance of Y. Just told you that expectation is the same thing as variance in Poisson distribution. Now this I have done, that is just extra. This was not asked for. So let me put it in a box. So this is not asked for. This is not asked for. Basically, they were asking only for variance. Find the standard deviation of this thing. So we know that standard deviation is square root of variance. But first, the formulas are for variance. So variance of X plus Y, that's variance of X plus variance of Y, that is 13. Standard deviation is the square root. I would leave the answer as it is in the exact form. No need of changing it into decimals unless otherwise stated. Find the standard deviation of 5x minus y. So variance of 5x minus this thing, but this becomes plus. Variance is always added. Don't forget the squaring. That is 229. Standard deviation is square root of 229. Again, write that you have left the answer in the exact form. if they would have asked for expectation, that is expectation of x plus expectation of y. If they would have asked for expectation of 5x minus y, minus means a minus over here. And then there is no squaring over here. Question number 3. Now it says the times in minutes taken by students to complete a test have a mean mu and standard deviation sigma. The times taken by a random sample of 100 students are noted and are used to calculate a 95% confidence interval for mu. Given that the endpoints of the 95% confidence interval are 31.02, 33.98, correct, 2, 4 SF, calculate the value of sigma. So the width, that is the difference between the two, and this comes out to be 2.96. And I have used that width over here. The formula is simple, 2z sigma over root A. So now, what is the confidence interval? 95%, 2.5%, 2.5%, read for 97.5. And then you find the value of sigma, 7.55, 3 SF. The calculation of confidence interval required the use of central limit theorem. Explain why it is valid. It's valid because the sample size is large. N is greater than or equal to 30. What is the value of n? That is 100. Then this one was a very nice question. A lot of people were going all crazy about it. There is nothing special in this except they have asked something from S1. So this knowledge of S1 is asked for. Of course, there are questions like this in Poisson also, but this they ask from binomial. A researcher calculates R of 95% confidence interval for mu. Find the largest value of R such that the probability all R. So probability X is equals to R, that is RCR. Remember, there were 3 cases that I explained to you in binomial. So if we say binomial X follows a binomial distribution with n comma p, we know that probability X is equals to 0, that is NC0, success raised to power of 0, Q raised to power of n. Probability X is equals to n, that is p raised to power of n, and probability of at least one of any event is 1 minus probability 0 of that event, 1 minus q raised to power of n. So these are the 3 different cases that we have studied. So this is the first one, that is q raised to power of n. The other one, that is p raised to power of n. The third one, that is 1 minus, and it's depending on the red one. So this is 1 minus q raised to power of n. So they ask these logarithm questions based upon this. So 95%, that's a probability of success. The number of trials is R. Find the largest value. That depends on the inequality, the final inequality. And the value of mu is greater than 0.5. So all these confidence interval, whatever the number that you choose, all of them, they have a probability of this. This is failure. This is success raised to power of this. Probability X is equals to n, p raised to power of n. This is p raised to power of n. Instead of n, they have written r. Got the idea? So now this 0.95 raised to power of r is 0.5. Take natural log of both sides. You can equally work with LG. ln of 0.95 raised to power of r, ln of 0.5. R ln 0.95 is ln of this thing. We have used a property of log, that is this thing, which is log x power m base a, that is m log x base a. So over here, that property is over here. This r comes down and multiplies. The next thing that we need to know is that log of any number between 0 and 1 is negative. So now when the coefficient is being multiplied with a negative sign and you remove this, what will happen? The inequality greater will flip and become lesser. And then you should draw a small number line. I wrote it without the number line, but you are aiming for that grade, right? So you should show all the working. So this is 13, this is 14, this is 12, this is 11, and so on. So lesser than 13.51. So somewhere here, it's like this. Lesser than 13.51. So now there is this integer, this integer, this integer. Which one is the greatest among these? So the greatest integer is 13. So just pick the integer in that direction. Since this is a lesser sign, therefore they ask for the greatest value, the largest value. So that was a very, very nice question. Keep this in mind. Now it says an inspector believes that 18% of the cups at a certain factory contain flaws. The factory owner claims that the true percentage is lesser. Now it's kind of different. Usually, the factory owner makes a claim, and that inspector is giving the alternative hypothesis. This time it's different. The inspector examines a random sample of 40, finds that 3 of them contain flaws. That is the sample value. And over here, stating a necessary assumption, use a binomial, test the factory's owner's claim at the 5% significance level. So yes, we are focusing on that claim, but the suspicion is by the inspector. So now over here, flaws are independent. These are all the conditions for binomial. The number of trials are independent. The probabilities are constant. There is a fixed number of cups. So write in the context of this question as I have written. X follows a binomial distribution 40, 0.18. P is 0.18. H1P is lesser than 0.18. A sample value is 3. This value is by default inclusive. We calculate a probability in this direction. Now look at the working. Over here, 40C0, success raised to power of 0, failure raised to power of 40. 1 term, 2 term, 3 terms, 4 terms. Just look at all the working that I have done. So show all these working, add it up, write in decimals, then multiply by 100, convert in percentage. So why am I converting it in percentage? Because we have to compare this value over here, this thing over here, with this significance level that is over here. If it's lesser, we will reject H naught. Since it's not lesser, do not reject H naught, accept H naught, and the examiner will be giving you marks on this thing. Insufficient evidence to accept owner's claim. Now explain why it would not be appropriate to use the Poisson distribution, Poisson approximation, because for Poisson, both conditions have to be fulfilled. Even if one is not fulfilled, you cannot do that. So first of all, n is not greater than 5, and still someone wants to calculate 7.2. So this is lesser than 5. It has to be lesser than 5. This is not lesser than 5. So I have written over here n greater than 50. That's not the case. So no need to check the second criteria. Question number 5. It says a random variable x has a PDF given by this thing. It's a cubic function. It lies between 0 and 2. Show that k is 3/4, that is 3 mark. Just a basic question. Put the constant on the outside. These are the limits. These are the two terms, the variables. Integrate. And now the good thing is when one of the variable is 0 and everything depends on this x, so that part disappears. So it's just about plugging in the upper limit. So now the upper limit, that's plugged in over here, that's plugged in over here. And then we simplify, we get this answer. Now it all depends on you, whether you want to do things like I'm doing, you want to use a calculator, work in fractions, any which way, but you need to give the answer as a fraction, not as a decimal. So this thing is done. Now it says the median of x is denoted by m. So now write down the value of probability x less than m. So we know that lesser than median is 50%, lesser than interquartile, lesser than lower quartile 25%, lesser than upper quartile 75%. Hence find the probability x lies between expected value and median. So we would be using this number line. So expectation is less, median is greater. We would be looking for this value in the middle. Lesser than median, we know that this is 50%. We have to calculate this probability. Let's say if this comes out to be 40%. I'm just giving you an example. So therefore the difference would be 10% and so on. So now the first thing that we need to do is to take this x and multiply with these two terms, this and this. And therefore after multiplication we get this thing. Don't forget there is 3/4 still waiting on the outside. That is the value of k. So that will be there all the way till the end. And then after integration, plug in the limits 0 and 2. Again, 0 has no use. So you plug it in, you simplify, you get 6/5, or you can write it as an exact decimal, that is 1.2. Probability x lesser than expectation of x. 0 is the lower limit, 6 over 5 is the upper limit. You plug in the value, and I think it's a better idea to plug in the decimal thing. So let me write over here. So that is 1.2, that is 1.2. And over here, I have plugged 1.2 over here, 1.2 over here, and this is the answer. Now the difference is this much. So this is 50%, this is 47.52%. So this one is 47.52%. So what is the difference between the two? The difference is this thing, 50% minus this thing, that is 0.0248 or 2.48% if you want to write in percentage. So that's the answer for this part. Question number 6. It says the weekly profit in dollars made by a certain firm has a normal distribution. In the past, the weekly profit had the distribution such and such. Following a change in management, the mean weekly profit for 35 randomly chosen weeks is this thing. So that is already the mean. So now X bar follows a normal distribution, 736, 26 square divided by 35. That's the number of sample. Sample mean value 725. Mean weekly profit is this thing. And what are they asking? Mean weekly profit has decreased. So it's a lower tail test. It's at 2% significance level. Calculate the z value, x bar minus mu sigma over root n. That is this much. Now, for 2%, that is basically for 98%, the z value is 2.054. So 2.054 is over here, negative, because it's a lower tail test. So this is a lower tail test. Now let's double check the z value. Does it lie inside the critical region? 2.5. Yes, it lies inside critical region. Let me mark this value. So this z value, this lies inside critical region. That is the z calculated value. Therefore, reject H0, accept H1, and then this is what the examiner will be asking you. The reasoning, the conclusion in the context of this question. There is sufficient evidence at the 2% SL significance level that weekly profit has decreased. Now it says the mean weekly profit for another random sample of 35 weeks is found and a similar test is carried out at the 2% significance level. State the probability of type 1 error. So for normal distribution, probability of type 1 is the same thing as significance level of the test. So this is true for normal distribution. Of course, CLT falls into that category. If the mean weekly profit is now 718, find the probability of type 2 error. And now it's for 5 marks. So now first of all, for type 2, you need the acceptance region. So keep that in mind. When we talk about type 1, we talk about rejection region. When we talk about type 2, we need the acceptance region. So unless and until I have the rejection region, how can I flip it? So now since it's a lower tail test, so therefore z is lesser than or equal to this boundary value, H0 will be rejected in favor of H1. X bar minus 736 over 26 over root 35 lesser than or equal to this value. So therefore x bar is lesser than or equal to this value. That's the rejection region. Therefore the acceptance region is this thing. So that is the acceptance region, which is right over here. And this is the rejection region, that is right over here, based upon this thing. So probability of type 2 error. So probability of type 2 error, given that mu is 718, x bar greater than this thing, and we simplify, we get this value 2.042. So let me just remove this 2.042. That was a bit blurry. So 2.0, and then I think this is 4. Yes. And then there is 2, that is 1. So 9794. So this is 9794. There it is. So this is 1 minus 0.9794 after rounding off. This is the answer. They have given the range from here to here. So now let me just use my calculator and let me just double check if I've done everything correct. 1 minus 0.9794, that is 0.0206. So that's not 3, that is 206. and that is exactly in 3 significant figures. And that's about it. So this is S2, and this is October November 2025 variant 62, and that was a nice question. So now once S2 is over, then we will be having some sessions related to P3. Stay tuned for more, and take care everyone, and good luck for the exam tomorrow.